Okay, so now we are going to talk about trig derivatives. So if I want to find the derivative of sine, we could use the basic definition, the limit as x approaches 0 of f of x plus h minus f of x all over h. But how do we clean that up? Well, we would have to go back and do the sum and difference formulas of sine, and let's be real, no one even remembers that, let alone if you learned that back in secondary 3. So what we're going to do is we're going to kind of do this informally by inspection. So the graph below is sine of x, okay? And everything's in radians. So what we want to do, since we know the derivative is the slopes, we're going to make up our own little tangent lines, okay? So, and we're just going to pick some of the key points that we can do on a graph, and that's enough to kind of get the curve of one cycle. So like the idea is if we had x equals 0, what I want to do is I want to estimate what kind of slope do I think that is. And I think, you know what, maybe that's a slope of 1, okay? And it's all going to be relative, so if you said that was like a half, then that's fine. So on our derivative, I'm going to keep it in red. We're going to go plot 1, okay? And then I want to go to pi over 4. And I say, okay, well, if I would draw this tangent line, well, how does it compare to this one, okay? And so I think, well, so this one looks a little steeper. So if I picked this, I'm going to say like that's 0.8. So at pi over 4, I'm going to graph 0.8, okay? And I'm going to pause, but I'm going to do that for each of these key values, all right? That's the idea. Okay, so I wrote all my slopes and then I plotted them on the red dots. And so we're going to kind of connect it. So if I connect this, and notice like they would be smooth, it's not going to be an abrupt line. But if I connect these tangent slope values, this is the derivative, oops, ran out of room, derivative of sine in purple, okay? And so we say, well, really, what graph does that look like? Hopefully it looks familiar. Yeah, that is the graph of cosine. Which means that the derivative of sine is cosine. And we could go through all the trig functions, and that's what we would be looking at, okay? So I didn't write my table of values here. I just wrote them on the graph. And I could do the same thing for cosine. For time's sake, I'm not going to. But what ends up happening is if I found all my slopes, like right here, if I started at 0, well, that would have a slope of 0. And then here, and I would do all of these. Negative 1. And I would go through. What ends up happening is, I know this is 0. And then this one's also 0. And it ends up being informally that, which, well, it starts at 0, so does sine, but instead of going up first, it goes down. So that's actually negative sine of x, and that's the derivative of cosine. All right? Now, sometimes to do the derivatives, you'll have to, these are all the algebraic proofs of tangent, cosecant, secant, and cotangent, because those are a little bit harder to prove using a graph, but I proved informally sine and cosine. All right, and so instead of you will never have to prove these derivatives, just so you know. What you need to do, attention please, is memorize these derivatives. Now, that is a lot to memorize, and so we want to kind of look at some patterns. So what do you notice? Well, what I notice is that the s derivative doesn't go with an s word. I know sine is positive, tangent is positive, secant is positive. And so what I notice is all trig words, their function, have negative derivatives. Okay, so that's kind of important because sines are important in math. Sine and cosine are the opposite. I notice tangent is secant squared and cotangent is cosecant squared. I don't have an easy way to remember that. You just have to. Cosecant is cosecant times cotangent. And look, cotangent and cosecant went together. So the C words. And then secant is secant times tangent, which tangent is secant squared. So these are the 6 that you do need to memorize, okay? Now, if we don't just have x, what happens is you really do have to do a chain rule, which means you would have to multiply by the derivative of the inside. And so you're going to start seeing that written as times dx, and that means times the derivative of x, which x just represents a generic function. Okay? All right, so we are going to practice that here. So I've got a bunch that look very similar. And you want to try to simplify. Now, the nice thing about trig is honestly, some of your answers using identities, they might look different. So be flexible. These would be multiple choice. So if you get an answer that's not on my answer key, it doesn't mean it's wrong, but you want to try to get your answer. You want to keep going until you get it to look like mine. Okay? Because that's what would happen on a multiple choice test. You don't always get to pick the answer that you want. You have to pick the one that they decided. All right. So on the first one, it's 2 times sine. So remember, when you multiply, I can just take that 2 and then I want to multiply by the derivative of sine, which is cosine. And there's nothing to clean up. So that's done. All right. Now this 2 I put inside. And so because that's not just x, I really need to do a chain rule. So the 2x is inside and that sine is on the outside. So remember, when you do the chain rule, you start with the derivative of the outside function. So the derivative of sine is cosine. The inside has to stay the same. You don't really need parentheses, but I just like to put them there. Okay? The inside is never going to change. Times the derivative of just that 2x, because that's the inside, which is 2. And so we usually like to put that 2 in front because I can't change the inside. So we get 2 cosine of 2x. It's a double angle formula, but we don't change it. All right. Now, number 3 is always tricky the first time you see it. This squared, that's how you write trig when you have powers, but when you do derivatives, that's not helpful. So you need to rewrite that 2 on the outside. And so what I notice is this is the inside. The 3 is kind of irrelevant because it just gets multiplied. And on the outside, we have a power. So when we do our derivative, we're going to start with the power rule, which means we're going to bring that 3 down with multiplication. The inside stays the same, and we subtract 1. Then we go and we do the derivative of the inside. I already remember that if it starts with a c, my derivative's negative. But until you have these memorized, you might want to refer to this list. So the derivative of cosecant is cosecant times cotangent. All right. And now we just clean up what we can. There's not much, but I can take this negative and multiply it by the 6. And then I do have 2 of those. So we're going to put those back together. And so it's kind of odd. Wait, the derivative of 3 cosecant squared x is negative 6 cosecant squared cotangent x. I don't try to make sense of these derivatives. I just do them. Okay? All right. Now, number 4, I first want you to recognize that that is not multiplication because it's not sine of x times cosine of x squared. It's the sine of cosine x squared. So this is inside and this is outside. So we're going to start with the derivative of the outside. The derivative of sine is cosine. Its inside stays the same. Then I need to do the derivative of this inside. But wait, cosine of x squared, it has an inside and it has an outside. So yeah, you're going to do a chain within a chain rule. So we start by taking the derivative of cosine, which is negative sine. That inside stays the same. Then I'm going to multiply by the derivative of its inside, x squared, which is 2x. Okay? So to clean this up, there's not much you can combine, but I can take the negative times 2x, and the cosines don't cross out. Usually we put alphabetically first, but it really doesn't matter. Okay? All right, look at number 5. So number 5, I do have x. So this is actually 1 and 2 functions being multiplied together. So that's a product rule. 1 d2 plus 2 d1. So our first function is sine. The derivative of cosine is negative sine. Since we don't have an inside, x just stays x. It makes it easier. So 1d2 plus 2. And then the derivative of sine is cosine. All right, so I could have negative sine squared plus cosine squared. And we do have a Pythagorean identity that's sine squared plus cosine squared. There are some double angle formulas, but for right now, we're going to stick to this really doesn't simplify. That could be an option. All right, number 6. This x squared is inside. So that's inside, and then that's outside. So our derivative, go up to your list. So the derivative of secant is secant tangent, and the inside stays the same. Okay? Then I multiply once by the derivative of the original inside. So don't look at what you wrote. Always go back to your original problem. The derivative of x squared is 2x. So the only thing you can do is really put that in front. We can't combine anything, and secant and tangent wouldn't reduce, or we would have a different derivative. Okay, let's look at number 7. I do want to rewrite this. So this is inside, and this is outside. So we start by taking the derivative of the outside tangent, which the derivative of tangent is secant squared. The inside stays the same, so I'm just going to write it back as that root x. Then I ignore tangent altogether when I go to do the derivative of the inside, which is a power rule. So 1/2 and subtract 1. So there's not much we can do. I'll put a fraction here, put things where they go. But remember, these x's do not cross out because that's inside a trig function. All right, number 8. Once again, we have a root. So we've got cosine of x squared to the 1/2. So on the outside, we have a power rule. And on the inside, we got a lot going on. But we always worry about the outside first. So the outside is a power rule. We bring the 1/2. The inside all stays the same, and we subtract 1. Then I'm going to ignore that, and I just do the derivative of the inside. Well, it has an inside, and it has an outside. So the derivative of cosine is negative sine. The inside stays the same. And then we multiply by the derivative of its inside, x squared, which is 2x. Yeah, this is a lot. So our final answer, the 2's would cancel. I would get, this is a negative x, so you'll see a negative and then an x. That's going to stay sine of x squared, and then this is going to be brought down. They might put this in a root, they might not, but that's flexible. All right, last one, number 9. These need to stay together. So this starts out as a quotient rule. There won't be any insides because we just have x. So low, and then d high. The derivative of 1 is 0. The derivative of sine is cosine. Low d high minus high. And then the derivative of cosine is negative sine. All over low squared. I'm just going to write it like that. I think that's easier to see. Okay, so let's see what we got. Cosine times cosine. 2 negatives, that would make that a positive. So now I'm going to distribute sine. So plus sine squared all over cosine squared. Now, this is a Pythagorean identity. Sine squared plus cosine squared equals 1. And so what that means is I could rewrite these because they're just being added. But if I have sine squared plus cosine squared, I really do get to replace that whole thing with 1. So on top, you actually only have 1 plus sine all over cosine squared. Okay? They try to get the least amount of trig words as possible. Okay, so you give yours a go and see how you do.